Hi, hello, welcome back to class, and thanks for logging in to complete today's lesson. And today's lesson is going to be on isotopes and average atomic mass, which is where you are right now. And there's a prerequisite for this lesson, and the prerequisite is that you must have completed the lesson on atoms, which was the one from the last class period. So that is this one right here, atoms. You must have completed this before you can excuse me, before you can do this. And then you click on here to start, which is where you are right now. And then once you've done, you click on next. That will lead you to the engage video. It's a kind of a very funny video just to start you on the lesson for today. Once you're done with that, you click on next. That should take you to the next activity, which is on atoms and isotopes. This is a kind of a simulation activity. You click on this link here. That will open the PhET simulation in a different window, and then you may just have to go back and forth between that window and these activities here. Please go through this. This information is very important for you to know to be able to complete this activity. I will also encourage you to write this down in your notebook. I believe you have a composition notebook for this class. Put this down as notes so that you can reference it as you complete this activity. Now the PhET simulation should help you complete this. So once you've done with that, so this is going to be your PhET simulation. You're going to use it to build the atoms, and based on what you did here, you go back and record and enter it in the atomic number. For example, for hydrogen, which is what you have here, this is hydrogen ion. You can see by putting one proton in there, I have a hydrogen, and you can see there's no electrons here that cancels out the charge on the proton. So this is going to be hydrogen ion, not hydrogen atom. So you have to know the difference between both an ion of hydrogen and an atom of hydrogen. Atom of hydrogen has no charge, whereas an ion of hydrogen has a charge because the electrons and protons are not equal. So we use this as a first example. So for hydrogen atom, the atomic number from this PhET simulator is 1. You can see right here, that's atomic number 1. So you go in there and put in 1. And then for protons, the number of protons here is 1. That's the one you have in the nucleus of the atom. So I'm going back here and put in 1. And then you see for neutrons, here there's no neutrons here, because neutrons, if I put a neutrons here, that would change the mass number. But there is no neutron, so which means that here I'll put a 0 in there. And then the number of electrons, there's no electrons. So the number of electrons here is 0. So I'm going to put 0 right there. And then the charge is the charge you have on the atom, in this case plus ion, which is right here plus 1. So you go over here and put in plus 1, and then you indicate if it's a neutral atom or an ion. It's right here. You already been shown that this is an ion, it's not an atom. So I'll go back here and put ion, so you can check and let's see if we did it right. So in this case, everything is right. That's what you're going to do for the rest of this. So help you practice, get used to writing the symbol of an atom or of an ion. Now once you're done with that, you click on next to move to the next activity, which is going to be a knowledge check. Want to see if you understood what you did in the previous activity. Alright, so you complete this, and as usual you check, see if you got them right. If not, try again. Refer to your information in your notebook and then try and see if you can get them right. So once you click on next, it gives you the next activity on neutral isotopes. As usual, I need you to write this information down. These are all notes. Put them down in your notebook so that you can refer to it and then practice using this activity here. See if you can, using this information that you have, knowing that mass number is equal to protons plus neutrons. You're able to find the number of protons when you're given the mass number and the number of neutrons, as well as being able to find the number of neutrons when you're given the mass number and protons. So use the information here and the example to complete this as a form of practice before you go ahead and complete this other worksheet at the bottom. So it helps you gain confidence in calculating atomic number, the mass number, the protons, neutrons, and electrons. Remember, you use the periodic table to find the atomic number. And also take note of this number after this symbol. So this number after the symbol, for example, nitrogen-15, means that nitrogen, this isotope of nitrogen, has mass number 15. So this is the mass number you're going to use. You're not going to use the mass number in the periodic table. So use the mass number of the isotopes that is indicated in this activity. Alright? But the atomic number is the same as the one you have in the periodic table. Once you've done with this, click on check before you click on move on to the next activity, which is exploring natural abundance of isotopes. So this is also a PhET simulation. So you're going to click on this to open it in a different window and then use that to complete this information or this worksheet you have at the bottom. And then check and see if you got them right before you move on to the next activity. Please make sure you always try and redo it. If you don't get all of them right, check, see what you did wrong and do it differently and see if you can get them right. Now this is a discussion question which I expect you to answer. Why are isotopes with different masses still the same element? So based on your activities that you did, I expect you to be able to explain, give a very short, maybe 5-sentence explanation of why they are different. And then after that, you click on next. That will lead you to exploring average atomic mass. This is one of the major part of today's lesson. You've been able to calculate the average atomic mass of an element. So you're going to use this simulation. Click on this to open it in a different window, and then you're going to use that to complete these different activities. Calculating. Please look at the examples that you've been given. Okay, so the explanation right here. Follow these steps. If you follow these steps, you should be able to calculate the average atomic mass of those elements that you're given. Now, if you click on next, once you've done this, check each one that you did. Now, once you do complete that, click on next. That will also give you more practice on calculating average atomic mass. Now, this activity is same as the one in the previous window. So, if you feel you're confident in calculating average atomic mass, you could skip this. If not, I need you to do that. And then before you move on to the next, you click on next to give you the next activity after that, which is this elaborate page. This is just informational. So you see how isotopes are used in carbon dating. Carbon dating is an example, it's just one of the several examples in which isotopes are used in everyday life. Okay? We will see more examples in the synchronous session. Now, once you're done with this, just go through this chart. I need you to complete this evaluate portion of this lesson. This is going to be for a grade. Okay, so I will need you to complete this, enter the information there and check, and then just like the instruction says, submit a picture of the work you've done, and then just take a picture of it and then you turn it in for a grade. And that will be all for this lesson. Okay, so please, if you have questions, log into the synchronous session and then we will explain some more or answer your questions. All right, thank you. Good luck.